All right. Okay, so let's talk about matter for a minute here. It says matter, again, is anything that has mass and takes up space. We looked at that earlier on. But mass and weight are two different things. Now, this again is, these are two words that are used kind of synonymously, just like we were talking about offline. My students and I were just saying, heat and temperature, sometimes these are used for the same thing, but the heat and temperature are two different things, and mass and weight are in fact two different things. Mass is actually a measure of the quantity of matter, and the SI unit of mass is the kilogram. Now, if you're wondering, what is a SI? What is that? SI stands for Système International. Okay, so Système International, or the international system, which is assigned a unit that is agreed upon by the scientific community. So the standard unit of mass for the scientific community is the kilogram, which we abbreviate lowercase k, lowercase g. Now, in 1 kilogram, there are 1,000 grams. So 1,000 grams in 1 kilogram, or 1 times 10 to the 3. If you want to express 1,000 in scientific notation, that is how you would do it. Now, weight, on the other hand, that is something else, right? Weight is something else. How much do you weigh? Well, it depends. It depends on where you are, because weight is a measure of the force that gravity exerts on an object. And gravity isn't the same everywhere in the universe, is it? It's not. Okay? Say, for example, you measure your weight on Earth, and then you were to measure your weight on the moon. Well, if you want to calculate your weight, what you can do is you can use this simple formula here and say weight is equal to C, which is a constant, times mass. Now, that constant C is going to vary. It's going to vary depending on where you are. And on Earth, C has a value of 1. So if your mass is, let's say your mass is 92 kilograms, or, let's say it's 80 kilograms. Well, on Earth, your mass is going to be 80 kilograms, but on the moon, the factor C is actually around 0.1. So that means that on the moon, your weight is actually only a tenth of what it is here on Earth. And so you can see that you don't always weigh the same, because weight is based on gravitational force. And if you weighed, let's say you weighed 200 pounds on the planet Earth, that means that in outer space on the moon, you would only weigh 20 pounds. And that is why astronauts appear semi, weightless. And that's why they're able to jump around on the moon and make these big, long, jumps or whatever, is because they don't weigh nearly as much. Their mass is still the same, but the gravity acting upon that mass is different depending on where you are. Okay? And to summarize that, you could just say if you had 1 kilogram bar, it weighs 1 kilogram on Earth, but the weight on the moon is only 100 grams, or 0.1 kilograms. All right, so mass and weight, two different things. You want to make sure that you know the difference between mass and weight. Let's talk a little bit more about this whole SI thing, this whole international system of units, because the scientific community has a whole series of agreed upon units that we use depending on the type of measurement that we want to do. Now, the base quantity, or the fundamental unit for all of these measurements, like length, mass, time, current, temperature, amount of substance, and luminous intensity, are all found on this slide. And you can actually derive any other unit from the 7 units that are found on this slide. So for length, we use the meter, which is abbreviated M. For mass, we use the kilogram, which is kg. For time, we use the second. For temperature, we use the Kelvin. Now, some of you may not be familiar with the Kelvin temperature scale. You might be wondering, well, how many Kelvin is it out today, or out this evening? Well, we'll talk about what a Kelvin is. And then for the amount of a substance, how much of a substance do you have? It's based off of the mole, M-O-L-E, which is abbreviated M-O-L. Pretty good abbreviation, huh? Anyhow, the reason why I didn't highlight electrical current and luminous intensity is because they aren't going to come up in General Chemistry 1. Okay, they're not going to be part of the course, so we're not going to stress about them a whole lot. But you need to be aware of these base units, and you also need to know how to convert these base units into other units. And we're going to do some unit conversions. Now, something else you might notice about the 7 units that I have highlighted, or sorry, the 5 units that I highlighted on this slide, is that only one of them has a prefix. You notice that the kilogram has the prefix kilo, right? A kilogram, because you saw earlier that in 1 kilogram you have 1,000 grams. Well, here is a list of all the prefixes that are used with SI units. Now, if you're wondering, do you have to memorize all this? You have to know some of them. The ones that I recommend that you know are from mega all the way down to pico. And if you're wondering, oh man, how am I going to ever memorize that? Do I just sit down and keep looking at zeros until I have it all in my head? Well, you can trust me that if you do enough practice, if you do all the practice problems, you will start to become familiar with these quite quickly. So mega is 10 to the power of 6, kilo is 10 to the power of 3, deci is 10 to the negative 1, centi is 10 to the negative 2, milli 10 to the negative 3, or 1,000th, right? Micro is 1 millionth, and then nano is 10 to the negative 9, and pico is 10 to the negative 12. Now, if I can be completely honest with you, and I like to try to be as honest with my students as possible, the prefixes that you're going to use the most are going to be things like kilo, deci, centi, milli. Those are the ones that are going to come up the most, okay? So if you're thinking, oh, I got limited time before I start the practice problems, you might just want to focus on those 4, and that can get you a pretty, that can get you through 95% of the problems that we're going to look at in this class. Let's talk a little bit more about volume. It says here that the SI derived unit for volume is the cubic meter. Now the SI unit of length is the meter that we abbreviate with a small m. And again, the SI derived unit for the volume is the cubic meter, which is m to the power of 3. And you see it over here and over here. Anyhow, generally, however, chemists work with much smaller volumes than a cubic meter. Things that a chemist would work with would be something like a centimeter cubed or a decimeter cubed. So you see here that 1 centimeter cubed is equal to a milliliter, and that 1 decimeter cubed is equal to a liter. Those are the types of units of volume that we are going to use a whole lot in this class. In fact, we'll never measure out a cubic meter of anything in this class. Now, you see that 1 centimeter cubed is equal to 1 times 10 to the negative 6 meters cubed, and that 1 decimeter cubed is equal to 1 times 10 to the negative 3 meters cubed. And how did I do that conversion? Well, I used the number of meters that are found in a centimeter and the number of meters that are found in a decimeter in order to do that. Now, if you're a little bit lost on the math, if you're like, oh, I don't see how you did that, we're going to look at examples where we do unit conversions and get a lot of practice in that. Another common unit, again, is the liter. A liter is the volume occupied by 1 cubic decimeter, as I just said. And 1 milliliter, again, is a cubic centimeter. Now, if you look at this figure here on the left, it compares the relative sizes of 2 volumes, the cubic centimeter and the cubic decimeter. Even though the liter is not an SI unit, volumes are usually expressed in liters and milliliters in this class. And so most of the time in this class, we're going to be dealing with liters and milliliters. And so it's imperative, if you want to start the practice problems tonight, that you know that 1 liter has 1,000 milliliters and that 1 milliliter is equal to 1 centimeter cubed. I'd say that those 2 conversions, let me put a green arrow by those. With those 2, you can get through quite a bit of content in the book. All right, let's look at one more slide before we take a break for the evening until our next class, and we'll talk about density. And density is the measure of the amount of mass per unit volume. Some of you may have heard of the formula density is equal to mass over volume, which we sometimes abbreviate as D is equal to M over V. Now, if we think about our mass as being measured in grams, and we think about our volume being measured in milliliters, let's say, then the units of our density would be grams per milliliter, right? And oftentimes, many of the densities that we will see in this class will be reported in grams per milliliter. Now, since we know that 1 milliliter is equal to 1 centimeter cubed, it follows that 1 gram per milliliter is equal to 1 gram per centimeter cubed. And we can also convert that into kilograms per meter cubed. I'm going to tell you right now that sometimes students try to use these units of kilograms per meter cubed when they want to look things up on Wikipedia or something, but those are generally not used in chemistry class. Here are some densities of some substances. It gives you an idea of the amount of mass per unit volume. You can see that water is around here. It's got a density of 1 gram for every centimeter cubed, or for every milliliter. Remember, we could write these units as grams per milliliter. You think about something like air, right? Air is much lighter than water. It's much less dense. Ethanol is a little bit less dense. It's somewhere in the middle. And then if you think about something that's really dense, you might think about something like osmium. I think osmium is the densest of all the elements. It's 22.6 grams per centimeter cubed, or grams per milliliter. And so you can see that that would be a way to differentiate between substances, would be to measure their densities and then compare them to the values found in a table like the one shown here. I ended that just in the nick of time.